Nanoscale particles of semiconducting materials is known as quantum dots. The example of semiconducting materials may be gallium arsenide and cadmium selenide. The physical properties of nanomaterials, particularly the optical and electrical, are strongly affected by quantum size effect. Optical spectra changes with dimension. As here this particular circle or sphere have a large dimension, it shows a golden color. If we reduce the size of that one, it shows a reddish one. As we again further decrease the size up to a nanometer, it changes its color. And if we further decrease the dimensions of this one, we get a colorless dot or quantum dot. So it ultimately reflects that the optical spectra changes with dimensions. Due to extremely small size of quantum dots, the electrons inside it has a unique behavior. Electrons are confined to very few energy levels as compared to allowed energy levels in bulk materials. So the quantum dots emit very intense light of a particular color when electron make transition between these few energy level. So to obtain broad range of colors, one has to control the size of quantum dots. So this is the explanation for such an effect which is shown by a different materials. As the material is bulky one, it shows a different color, but if we reduce the size of that material, it emits a different type of color. When energy is provided to electrons in silicon material, it will lose in the form of heat. No radiation will be emitted as the material is in bulk state. But when the immediate silicon is finely divided into nanometer size wires, that means we have make the nanometer size wires using the same material, that is silicon. It will emit light. This is known as porous silicon. As the size of wire reduces, color changes from red to blue. So ultimately we have discussed or we have learned that as the size of a particle reduces, it shows a different behavior, and that behavior directly affects the optical and electrical properties of that material. So we have understood the quantum size effect. From this we have understood that the physical properties of nanomaterials are quite different than that of the bulk materials. So in the next one we will discuss the properties of nanoparticles. First we will look at the optical property, which are mostly affected due to the size. In optical properties we will discuss some of the examples. The glasses of the windows of old palace, churches, house are made by dissolving small amount of metal particles like gold, silver, iron, etc. These windows are designed with beautiful tinted glasses. Depending upon the dissolving metal particles, the colors like red, pink, blue, etc. can be adjusted with such transparent glasses. It is mainly due to metal nanoparticles. We have observed such type of glasses on old churches or on old palaces, where they have used the metals like iron, nickel, gold, silver. From this one they have used a different colors. The scientific study done by Faraday in 1857 shows that gold metal nanoparticles produce intense red color against yellow appearance of bulk gold metal. The next one, we will discuss the electrical properties. Electrical properties of nanoparticles have a very high surface area to volume ratio. This provides a tremendous driving force for diffusion, especially at elevated temperatures. Nanoparticles have been found to impart some extra properties to various day-to-day products, like the presence of titanium dioxide nanoparticles impart what we call as the shelf cleaning effect, and the size being nano range, the particle cannot be seen. Another example is nano zinc oxide particle have been found to have superior ultraviolet blocking properties compared to its bulk substitute. This is one of the reasons why it is often used in sunscreen lotions. These nanoparticles are hard and impart their properties to polymer. Therefore, nanoparticles have also been attached to textile fibers in order to create small and functional clothing. Briefly discussing the electrical properties of nanoparticles are: it have high current density per area cross section, it has variable electrical conductivity, it has high heat conductivity, it is anisotropic thermal conductivity, superconductivity under certain conditions, and field emission properties. In the next one, we will discuss the magnetic properties. In electronic circuit, like transformer, motors, information storage, that is memory devices, magnetism of material shows very important application. Magnetic nanoparticle assemblies of nanoparticles, magnetic nanowires, magnetic thin film or multi-layer films, and metal oxide film doped semiconductor particles or thin film have become the focus of attention due to their magnetoresistive or magneto-optical properties. The surfaces and interfaces play an important role in the magnetic properties of material of nanostructures. We will discuss its structural properties. The structure of nanoparticles are not just the fragments of bulk material, whereas the structure of nanoparticles can be entirely different. Bonds and bond strength in nanomaterials can also be totally different. It is found that the lattice parameter may not be the same as in the bulk material. An analysis of X-ray diffraction pattern of zinc sulfide show that cubic structure in the bulk. The diffraction pattern of zinc sulfide as small as 1.4 nanometer particle had liquid-like disorder. It is also seen that there is a lattice contraction of 1% for 1.4 nanometer zinc sulfide nanoparticles. Overall, smaller particles also show up to 2 to 3% lattice constant deviation compared to bulk crystalline model. Next, we will discuss the mechanical properties. The mechanical properties of nanoparticles are: they have high Young's modulus, they have high tensile and compressive strength, and it is more flexible. Therefore, they find in many applications. In the next topic, we will discuss the applications of nanotechnology. After looking the properties of nanoparticles, that is optical, electrical, magnetic, structural and mechanical properties, we will understood the applications of nanomaterials in different fields. The first and the most important applications of nanomaterial is found in medical field. The initial test of various drugs delivery system that is cancer or tumor therapies have been successful by using nanotechnology. This is because of small nanoparticles can be easily injected and targeted toward the specific portion of the body. Gold nanorods, which have strong scattering and absorption property in the infrared light, are used to detect and destroy cancer cells. Drug can be encapsulated in nanocapsules and targeted toward the desired part of body. So ultimately, we can find the nanomaterials application in medical field, mostly for initial test of various drug delivery system, that is cancer and tumor one that are limited examples. Then next we will discuss the applications in automobile sector. Structural part of the simple car should be strong, non-deformed or rigid, in desirable shape and size. These are made of steel, some alloys, rubbers, plastic, etc. Nanotube composites have better mechanical strength than steel. Therefore, efforts are going on that synthesis of nanotubes can be replaced with the steel. Nanoparticles spray painting can provide smooth, thin, attractive coating. Very powerful motor using shape memory alloy are made using nanoparticles. They perform better and consume less power than other motors. Use of efficient nanomaterials catalyst may convert harmful emission into less harmful gases, and it ultimately helps in reduction of air pollutants. Next one, we will discuss applications in electronics energy. Single electron transistor and magnetic tunnel junction. Such type of new devices are based on nanotechnology. They find many applications. These devices are faster, occupy less space and relatively cheaper. To increase data storage capacity of hard disk, the spin ball type devices are used. The flat panel television or computer monitor are products of nanotechnology. Nanoparticles are used for coating on the screen of TV or monitor so that color quality resolution may get improved. These are some of the applications found in electronic industry. Now we will discuss some of the application in aerospace and space technology. There would be significant advantages of material which are 100 times stronger than present material. Objects made from the nanomaterials could be 100 times lighter. They are more tougher. Therefore, they can be used in aerospace. Space transportation cost could be reduced considerably with use of products of nanotechnology. In space technology, very low density material known as aerogel is nanoporous material. This material is used for various applications in spacecraft and military to reduce the weight. Nanoparticles of alumina burn at least 5 times faster than conventional particles. In satellite, as an ignitor, this type of material can be considered. So these are some of the applications of nanoparticles. They find in making the codes. They can find application due to their strength and low weight. They can be used as a fuel. So in the next one we will discuss the applications in environment. Nanomaterials help in reducing the pollution and environment related